In section 1.6 here, we're going to look at critical thinking and ethics as it relates to statistics. So remember, in statistics we're using rational thought along with our statistical methods to assess our data and the inferences that we get from the data. And an essential part of that process is going to recognize that there's variation in the data. So here's an example. We're looking at helmet laws here, and an article in the New York Times considered the question of whether motorcyclists should be required by law to wear helmets. And in supporting their argument for no helmets, the editor of a magazine for Harley-Davidson bikers presented results from a study that claimed here 9 states without helmet laws had a lower fatality rate, 3.05 deaths per 10,000, than those that mandated helmets at 3.38. The survey found that of 2,500 bikers at the rally, 98% of those respondents opposed such laws, so they opposed helmet laws. So based on this information, do you think it's safer to ride a motorcycle without a helmet? And if not, what further statistical information would you like? Well, personally, I would like some more information here. So first, consider who collected this sample. So notice here that it was an editor for a magazine for Harley-Davidson bikers. So this is a Harley-Davidson editor, which is not independent. So we would like if we had an independent organization like Gallup doing this. So if we're not independent there, that definitely introduces the possibility for bias. It's not an independent sample. Look at how the data was collected. So how did they collect this data? Well, he says here one study claimed, and they tell us 9 states without helmets had lower fatality than those that mandated. They really didn't tell us how they got that data. However, in the next statement, they said a survey found of 2,500 bikers at a rally, 98% of respondents opposed such laws. So the second batch of information was collected by a survey, which is not random. And that introduces the possibility for bias again. What would we want to know regarding the claim that 9 states without helmet laws had lower fatality rates? Well, we want to know is, the 9 states, are those all the 9 states? So we want to know, are the 9 states all without helmet laws? Or are they handpicked? Did we just pick the best ones? Cherry picked, if you want. And then we're comparing to it said compared to then those that mandated helmets. Those again, when we say those, is that all of those that mandated, or just some of them? See, we're really not told as much information as I would like to know. What do you think regarding this claim about 98% of the respondents opposed such law? Well, again, this is a survey. It's of the respondents. So, you get volunteer bias here. It's a volunteer survey. So volunteer bias is when the people that respond to the survey are the people that have the strongest feelings about what they're responding to. So you may not get a representative view, something that's representative of your population. So it definitely could be some volunteer bias in there. And then why did they oppose? We're not told anything about why they opposed. Did they oppose it for safety reasons or for convenience? Right? I mean, helmets are hot, they're heavy, they're uncomfortable. Who'd want to wear a helmet if you weren't mandated to? So all these kinds of questions need to be asked when you're doing an inferential analysis. And if your sample was biased on purpose in order to mislead the public, that's going to be unethical statistical practices. You don't want to purposely pick biased samples to get the conclusions that you want. That is misleading. So, and a big part of statistics out there is that there's a lot of misleading statistics, and people don't question statistics as much as they should. You hear something, especially from a good source, and you think, oh, it sounds so authoritative. But you need to have a healthy skepticism when it comes to statistics.